Welcome to Ask and Learn.
In this problem, we have a fairly complicated mechanism that's a relay. So we have, but it's fairly simple mechanically. We have this lever arm here that's attached to a pivot and held, supported by a spring, and then there's a contact up here. And so then we have a solenoid down here that, when energized, will pull this lever arm away from the contact, thus breaking the circuit. What we have here is a pivot force, which I'll call that 1, and then say that is the origin at our pivot point. We have the spring force here at a distance of 30 millimeters in this direction from the origin. We have the contact force, which we're told initially is given, and we want to try to figure out what the force in the spring is if this is 0.4 newtons. And that is 100 millimeters from the pivot in this direction. So now we have all of our forces and position vectors, and we can just sum forces and moments again. And really all we needed to do was sum moments, in this case about this point, because that will give us all the information we needed, which was F. But the other equations will tell you that V equals 1.73 newtons, and N is of course 0 because it's the only horizontal load. But F in this case is 1.33 newtons. And if that's the force in the spring, then that means the spring must have been displaced 11.1 millimeters. Now that's not the displacement of the arm here, that's the total displacement of the spring, which was obviously pre-compressed before it was inserted into the system. So we can then when we're asked to figure out what the force in the spring is when the solenoid is turned off and the arm is back down in this position and contact has been lost. So in that case, we know that the spring's displacement, or the change in length of the spring, will be this change in length plus the change in length from the arm pivoting back to its regular position, which is 30 millimeters times sine of theta of 10 degrees. And this gives us 16.32 millimeters. Plugging that into our spring equation, knowing the spring constant is 120 newtons per meter, we get that the spring force in this case is 1.96 newtons, which is obviously larger than this because now we don't have the solenoid acting on opposite of the pivot point.